Okay, starting with 3C, where we left off in class, we have 9 square kilometers. We want to convert that to square miles, round to the nearest tenth. So what we want then is square miles. What we have is 9 square kilometers. And then if we look in our notes at the USCS to metric conversion, we have two options. We can either say that 1 mile is equal to 1.6093 kilometers, or we can say that 1 kilometer is equal to 0.6214 miles. Now you can use whichever one you want. Like I said in class, I generally like to use one that doesn't start with a 0. So I start with this one. If I use this one, when I'm setting up my table, I want to have square miles here. Right now I don't have anything in square miles. I only have one-dimensional mile. So to get from one dimension to 2 dimensions, I need to square it. So multiply by itself. So 1 squared is 1. So 1 square mile. So I have 1 mile by 1 mile. And then we have 1.6093 by 1.6093. So I'm going to square that. So I just put 1.6093 and then the caret and then 2 in the calculator. And I get 2.589846 rounded. Now, be careful that when you are rounding, I think there was a couple other numbers after this in the calculator. You either write down everything to try to avoid rounding errors, or at least probably at least 5 out will be good enough most of the time. So now I have a square mile that I can put in here. So I have 1 square mile and 2.589846 square kilometers. So now I don't want kilometers in my answer, I only want miles, so I need to cancel out my square kilometers. So back in my have list, I have 9 square kilometers and nothing else that describes that. So kilometers cancel, I'm left with this miles, so I divide it, so I have 9, 1 times 9, so we have 9 divided by my 2.589846. And round as the nearest tenth gives me 3.5 square miles. Okay, so far we've used a table where there's been like a one-to-one conversion here. But sometimes there isn't a one-to-one conversion. We have to use formulas instead. So one that we generally do that for is for temperature. So to get from Fahrenheit to Celsius, so Fahrenheit is more the United States version and Celsius is more the metric. Because Celsius freezing is 0 and boiling of water is at 100, whereas Fahrenheit's 32 and 212. So these are essentially the same formula to solve for the different variables. So this first one is if you have Fahrenheit. I'm sorry you can't really see it in the video. So if you have Fahrenheit, then you put it in this one and you can solve for C. If you have Celsius, you can put it into this one and do the calculations to get F. So for this one, if we start with 40 degrees Fahrenheit, that means we want Celsius. So we always want our want to be on the other side of the equal sign. So we want our Celsius equals. So we're going to use this one here. And instead of F, I'm going to put in a 40. So my C is going to be equal to 40 minus 32 divided by 1.8. Now I can do this by hand, or I can try to simplify this by hand using order of operations, meaning we'd have to subtract the top and then divide. Or I can just put the entire thing in the calculator. But notice that because there's more than one number up here, if everything's multiplied, it's okay. But if there's ever any addition subtraction up here, you have to put parentheses. So I'm going to put parentheses 40 minus 32 divided by 1.8. And I get 4.4 repeated. They want it to round it to one decimal place, so this would be 4.4 degrees Celsius. Okay, for part B, we have Celsius now, and negative 35 degrees Celsius, and we want Fahrenheit. So now I'm going to use the formula that has F equals. So we have F equals 1.8. Now this is 1.8 times C, so 1.8 times a negative 35 plus 32. And again, I can just put that in my calculator. Notice though that for the negative 35, I am not going to use the minus button. I'm going to use this negative button. So we have a negative 35 plus 32. Now if you did use the minus sign, you'd end up getting a syntax error. It would say syntax here. And we get a negative 31. So these are the conversions for these two. Now for number 5, what you're going to do is you're going to convert between Celsius and Kelvin. Now note, it's not all that important, but note that Kelvin does not have that degree symbol. Kelvin is like the scientific unit where 0 Kelvin is like absolute 0, where nothing is colder than that. So go ahead and try that one. And we're going to move on. Okay, number 6, your utility company charges 12 cents per kilowatt hour of electricity. Part A, what is the daily cost of keeping lit a 150 watt light bulb for 8 hours each day? Round to 3 decimal places. Okay, so what is it that we want here? We want a daily cost of keeping lit, all that information. But daily cost is the essential what we want to find out. So what we want is a cost per 1 day. What we have. So starting from the beginning, we have charges 12 cents per kilowatt hour of electricity. So 12 cents, $0.12 per, now kilowatt hour. So remember in 2A, we mentioned that the hyphen means multiplication. So this means 1 kilowatt times 1 hour of electricity. And so in our table, we'll just take that one at a time. And I'll show you that in a minute. Okay, so other things we have a 150 watt light bulb. So that light bulb uses 150 watts. And it's run for 8 hours each day. So we have 8 hours. Each is another way of saying per day. Now note we have different time measurements here. Normally we would say there's 24 hours in a day, right? But this, right, so this 8 hours is how long it's being run. So this hour is talking about your run time. And this day is a calendar day. So the full 24 hours. So 8 hours out of the full 24 is being used. So because we have to say that, we're going to look at the other ones here. So we have hour and we have day here. So this hour, because we're talking about like the cost, you're only going to get costs. You're only get charged for the time you actually use it. So this would also be runtime. And this day, your daily cost though, that would be how much you pay for each day of the year. So this would be a calendar day. So these 2 days match and these 2 hours match. Okay, now we can start setting up our table. So we start with what we want. Specifically, we start with the numerator of what we want. Since we have 2, we start with the dollars. So looking at my have list, I have 12 cents per kilowatt hour. So I'm going to put that here. 1 kilowatt times 1 hour. And then from here, you have the choice of which one you want to start with. I'm just going to go left to right. So I'm going to first cancel out the kilowatt. Now looking back in what I've got, I don't have any kilowatts, but I do have watts. So notice the only difference between those is that metric prefix there. So what I'm going to do is I'm going to go ahead and convert this 150 watts into kilowatts. So using our mnemonic, we have King Henry died unusually drinking chocolate milk. So watts is here at the unit, and we want kilowatts, so we're going to go left 1, 2, 3 spaces. So right now the decimal point is here at the end, so I go 1, 2, 3. So that gives me 1.15 kilowatts. So instead of 150 watts, I have 0.15 kilowatts. So this is what I'm going to put over here, so 0.15 kilowatts. So now those cancel. And this is just the energy that a bulb uses, so there's nothing else with that. So kilowatts are canceled. Now I go back here and I want to cancel out my hours. Now remember, this is runtime hours. So what else do I know about runtime? Well, I know I'm running at 8 hours in one day. So I have 8 hours in one day. So my hours canceled. And now I'm left with dollars in the numerator, days in the denominator, which is what I want. So I can go ahead and multiply. So there's no numbers on the bottom except for 1, so we just do 0.12 times 0.15 times 8, and we end up with 0.144 per day, rounded to 3 decimal places. Okay, for part B, I'm going to start it and I'm going to have you finish it. So for part B, this is how much will you save in a year if you replace the bulb with an LED bulb that provides the same amount of light using only 10 watts of power, round to 2 decimal places. Okay, so it wants to know how much will you save in a year. So what they want is a savings per year. So in order to find the savings, that means we're going to take the yearly cost for the more expensive one, which of course the one who uses more electricity will be more expensive. So the yearly cost for the 150 watt bulb, and we're going to subtract the yearly cost for the 10 watt bulb. So this is kind of our plan for how to get there. So I'm going to go ahead and help you with the yearly cost for the 150 watt bulb, and then I'm going to have you find the yearly cost for 10 watt. Okay, so we want the yearly cost for 150 bulbs, which means it's $1 per 1 year. Well, right now we have $1 per day, so I'm just going to go ahead and convert that. So we're starting with 0.144 per 1 day, because we want to start with our numerator, which is dollars. And then this is a calendar day, and this is also a calendar year. So I can say there's 365 days in 1 year. So days cancel, I'm left with dollars per year. So then I multiply these two together, and I get 5256, because they want you to round to 2 decimal places, per year. Okay, so this is what the 150 watt bulb costs. So then you need to find out what the 10 watt bulb costs, and then you're going to take the 5256, subtract that number, and that will be your savings. Okay, number 7. In 1900, a certain country's population was 75 million and so on, and its area was 2.8 million square miles. Compute the population density. So density, if you remember from the lecture video, that's talking about the thickness of something, how crowded something is, how compact. And population density is given in units of people per area unit. So whatever area unit they use depends on the problem. In this case, they give us square miles. So whenever you have anything squared, that's usually an area unit. So if we want people per area, well, we have a population of this, so that's the number of people, and then we have this many square miles. So both of those are describing the same thing, same country. And so we can put it as a fraction, so one over the other. Now which one we put over the other depends on what we want. So we want people over area, so we're going to put the number of people, the 75,539,869 people, over the area, so 2,840,733 square miles. We divide that in the calculator and we're rounding to the nearest whole number. So that gives us 27 people per 1 square mile. Okay, for 8, doing similar thing, but this one actually requires a little bit of conversion. So for number 8, it says which has more people, County A with an area of 72 square miles and a population density of 36 people per kilometer squared, or County B with an area of 36 kilometers squared and a population density of 72 people per mile squared. So this time they give us a population density, whereas in 7 we were computing it. So I'm going to show you County A, and then you're going to do County B, and then you're going to tell me which one has more people. So what we want here is a number of people. So for County A, what we have is an area of 72 square miles and a density of 36 people per square kilometer. So setting this up, I start with what I want, which is a number of people. And what do I know about people? Well, I know that there are 36 people for 1 square kilometer. And then I need to cancel out kilometers or square kilometers, but I only have square miles, which means I'm going to have to convert between the two. So we used this earlier on number 3. So if we just look back on there and get that number, we know that there are 2.589846 square kilometers and 1 square mile. So square kilometers cancel. And now I need to cancel out the square miles because I only want people in my answer. And I have 72 square miles and nothing else describing that. So miles cancel, kilometers are canceled. So then just the denominator is 1, so I multiply everything across the top. And if I round to the nearest whole number, so the whole person, I have 6,713 people. Okay, so you figure out what it is for County B, how many people in County B, and then tell me which one has more people, A or B. Okay, number 9. A certain antihistamine is often prescribed for allergies. A typical dose for a 100-pound person is 24 milligrams every 6 hours. Round both answers to the nearest whole number. Okay, in this case, they give you the weight for a 100-pound person, but you're not actually really going to use it. Sometimes they do give you a little bit of extra information, but if you aren't sure about that, you can always list it in the have, and if you need it, you can use it. If not, then you don't. So for A, following this dosage, how many 12.3 milligram chewable tablets will be taken in a week? So first of all, figuring out what we want before even figure out what we have. So it says how many 12.3 milligram chewable tablets. So that right there is the main part of our question. Now, remember, when we ask them what we want, we don't want a number in the numerator. We also don't want a number in the denominator. We just want, we're going to say, want how many something. So here we actually have a description with a different unit. So we have milligrams, and then we have tablets, although chewable is kind of with the tablets. So chewable doesn't really make a difference when we talk about our units. So we have 12.3 milligrams also describing the tablets, which means that that's actually going to be part of my have, that there's 12.3 milligrams in 1 tablet. You have to be careful then if there's like 2 units right next to each other, that means you kind of have to separate them in the fraction. So going back to what we want, so it's how many, and we can kind of skip the description part, tablets. How many tablets, I want to know how many tablets would be taken in a week. So because we're looking at just 1 week, we can go ahead and say tablets per 1 week. So that's what we're going for. Finishing off our halves, we know it's 12.3 milligrams in 1 tablet. So looking back on our problem, we have a 100-pound person. So we can go ahead and put that we have 100 pounds here. We may or may not use that. And then we have 24 milligrams every 6 hours. So 24 milligrams. Every is another way of saying per 6 hours. So 6 hours time elapses, you should hit 24 milligrams. Starting my table, start with the numerator of what I want, so tablets. Then I have tablets here, so 1 tablet is equal to 12.3 milligrams. I don't want milligrams in my answer, so I need to cancel it out. I've already used that one, so we have 24 milligrams here for 6 hours. The milligrams cancel, so now I don't want hours, I want week, so I need to convert this hour into weeks. So right, this is like just the time that's passing, so there are 24 hours in 1 day, and 7 days and 1 week. Okay, so now we can go ahead and multiply. So multiplying everything across. So 24 times 24 times 7, we have 4032. Multiply everything on the bottom, so 12.3 times 6, we get 73.8. Dividing 4032 by 73.8 and rounding to the nearest whole number because that's what they asked us to do, we have 55 tablets in a week. Okay, so for part B, this antihistamine also comes in liquid form with a concentration of 12.3 milligrams per 7 milliliters. So that means our liquid is being measured in milliliters. Following the prescribed dosage, how much liquid antihistamine should a 100-pound person take in a week? Okay, so it says how much liquid antihistamine, remember that we're measuring in milliliters. Otherwise, you should be able to do this one. Okay, moving on to number 10. So we have a 0.8 liter bottle of Mexican wine, cost 99 pesos. At that price, how much would a half-gallon jug of the same wine cost in dollars? Use the conversion table in your notes, round to the nearest cent. Okay, so what is it that they want? They want to know, at that price, how much would a half-gallon jug cost in dollars? So they want to know the cost. Now, we could say the cost per jug, but in this case, they tell us how much a jug is, and they also tell us how much a bottle is. So in this case, I'm not really going to worry about what exactly they call the container. I'm just going to worry about the amount the container can hold. That wouldn't be wrong if you did put it in there. It just, there's a few extra steps in there, and I think that's what my math lab does if you ask about this one. So we want $1 for a half gallon. Now, I mentioned a few minutes ago that I don't like to have numbers in my want. So instead of having $1 per half gallon, what I'm going to do is I'm going to say that I have a half gallon. And then if I find the cost for the half gallon that I have, then that'll answer the question. So if I have a half gallon, see, what else do I have? I know that 0.8 liter bottle costs 99 pesos. So if I have a 0.8 liter, that is 99 pesos. And then that's all it gives me in the problem, but I know I'm going to have to go between pesos and dollars. So if I look up that from 2A, I have two choices. I'm going to take the one that doesn't start with a 0. So that tells me it is 21.86 pesos for $1, because it was in the foreign per dollar column. And then I also know that I have gallons and liters here. So I'm going to go ahead and look up that conversion. And using the one that does not start with 0, I say that 1 gallon is equal to 3.785 liters. Okay, so starting my table, I'm going to start with what I want, so dollars. So looking through my have list, I've got this currency conversion, so 1 goes with my dollar. So 1 up top, and then I have 21.86 pesos. Now I want to cancel out the peso. So I see what else do I have? Well, I have 99 pesos is what it costs to get 0.8 liters. So pesos cancel. So now I need to cancel out the liters. Well, I know that I've got 3.785 liters for 1 gallon. So the 3.785 here and the 1 gallon here. And then lastly, I don't want a denominator, so I still need to cancel out this gallons. So this is where I put the 0.5 gallons here and then nothing underneath it. So gallons cancel, everything's canceled except for dollars, which is what I want. Let's go ahead and multiply the numerator and denominator. Now the numerator, I get 187.3575. Denominator, I get 17.488. Dividing these two, I end up with $10.71, rounded to the nearest cent. Okay, number 11. The monthly rent on a 40 square meter apartment in Monte Carlo, Monaco is 1,500 euros. The monthly rent on a 450 square foot apartment in Santa Fe, New Mexico is $750. In terms of price per area, which apartment is less expensive? So saying which one is less expensive. So we need to figure out the cost for each, and they want it in terms of price per area. So they didn't specify which one, so we can pick whichever one we want. I suggest, you can do it differently if you want, but the way I would suggest doing it is using the terms you're more familiar with. So in the US, that would mean the price we're going to look at in dollars. Per means division. And then area, we're considering meters and feet. At least I understand feet better, so I would say square feet. So I would want to find the price per square foot in dollars for each of these, so I compare them to see which one is less expensive. So so you can do that one, just compare. So you're going to find Monaco's, and then you're going to find New Mexico, and tell me which one is cheaper. Okay, we are not doing 12 and 13. I decided I don't like those questions, so I'm taking them out of the homework. So go ahead and take a picture of what you did for the ones that we didn't do together, and you'll submit that in Blackboard. If you have any questions, you can also email me, and I will get back to you as soon as I can. Thanks.